Okay, in this video we're going to look at multiplication of functions involving power series. And before we get to some specific problems, just a reminder, you should be familiar with these power series for common functions. So the sine, the cosine, e to the x, maybe the natural log of x, you should have run across these earlier, and you'll need these as we go through the examples that we're going to use. Now, a specific example, let's just take a look at one. Our first example will be this. Suppose you want to multiply x cubed times the cosine of x, but you want to express the cosine of x as its power series. Now in this case, you've just got the cosine of a simple x, so you can use the basic power series for a cosine. So the first step will be just to go and look at your definitions here. Here's the definition of the cosine of x, and it's expressed like this. Now, most students by now in the course will just about have these things memorized. If you haven't, you might want to think about doing that because you'll use them pretty often. So the very first step is just take this definition of the cosine and write it down on your page. So we'll do that over here. So the cosine of x is defined to be this. Now again, in this problem, it's just the simple cosine of x, so you don't have to do any substitution to modify this thing first. So this is actually going to turn out to be a pretty straightforward problem. So let's just go ahead and express it. So first of all, you've got x cubed. So I'll put x cubed right here. And I'm going to multiply this times, and in place of the cosine of x, just put its expanded power series. So this would be 1, then I've got minus x squared over 2 factorial, then plus x to the 4th over 4 factorial, then minus x to the 6th over 6 factorial, and plus, and it goes on to infinity. So it looks like that. Now in this example, it's really very straightforward. All you've got to do is to distribute that x cubed. So x cubed times 1 is going to give you x cubed. Then you've got minus. Then add the exponents here. So 3 plus 2, this would be x to the 5th. And 2 factorial, we'll go ahead and change that into a number, is just 2. Then you've got plus 3 plus 4 would be x to the 7th, divided by 4 factorial, and 4 factorial is just 24. Then we'll stick one more on here. We've got minus, and again, 3 plus 6 would be x to the 9th, divided by 6 factorial, which would be 720, and then plus, and it goes on forever. And really, that's going to be the answer. So if it's just a basic power series where you don't have to use substitution, you can just start with the basic series, plug it in, distribute whatever the function is that's in front, and you've got it. So that's the first example, again, with just a simple x. Now in the next two examples, we'll make it something other than just a simple x where you'll have to use substitution first. So let's take a look at those. Okay, now in this example, you've got 4x squared times the sine of 2x. Now again, the function we're going to be working with here is the sine of 2x. So look back in your basic list, and in your basic list you'll have this. The sine of x can be expressed in power series form like this. So start by just taking this formula again and writing it down on the page. So we'll put that right here. Now the difference is this. We have got the sine of 2x, not just the sine of x. So this is kind of a two-step process. So step number 1, we'll call it step 1 here. Step 1 will be to find the sine of 2x. And we've done this in previous videos. And again, this is just using substitution. And all you have to do is everywhere you have an x, replace it with a 2x. So starting with this definition, we'll have, in place of x, we've got a 2x, then minus, and this used to be x cubed, so now it's 2x cubed, divided by 3 factorial. Then you've got plus, I'll put it in parentheses again, you've got x to the 5th, but now it's going to be 2x to the 5th, divided by 5 factorial. and then you've got minus, and it'll go on for infinity. So the next step is to go ahead and change each one of these into whatever the number is. So this was going to be 2x. Then if you cube this, you would have minus 2 cubed would be 8 over x cubed. And we'll go ahead and change 3 factorial into a 6. Then you've got plus, then 2 to the 5th would be 32, x to the 5th, divided by, and 5 factorial would be 120, and then minus, and it goes on, so like so. So this is going to get you to the sine of 2x, and we'll simplify these if we can. So I've got 2x, then minus, and this one's going to become 4/3 x cubed, and then plus, and if you simplify 32 over 120, you'll get 4/15. So 4 over 15, x to the 5th, and then minus dot, dot, dot. Okay, so what that does, that gives you the sine of 2x, so now you know what this is. So you have to do one extra step and use substitution to change it from the basic formula for the sine of x into the sine of 2x. But now you're ready to just multiply it out. So first of all, you'll have the 4x squared. So here's 4x squared. And then again, in place of the sine of 2x, just put it in its expanded power series form. So this would be 2x minus 4/3 of x cubed plus 4/15 of x to the 5th minus, and it goes on forever. Now, go ahead and distribute this. So if you distributed this, you would have, again, 4 times 2, that's going to be 8. And then x cubed times x, or x squared times x, would be x cubed. Then minus, and distribute this, you'll have 16/3. And again, x squared times x cubed would be x to the 5th. And then you'll have a plus. And again, the 4 times the 4 would be 16 over 15. And again, you've got 2 x's and 5 x's would be x to the 7th. And then minus dot, 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 and you'd be done. So in this problem, when you get finished, that's going to be the solution. But again, you have to add this one extra step here of, and I think I'll just kind of put it in red, is if it's anything other than just a simple x, you'll have to use substitution first to modify the basic formula to fit whatever the problem is that you've got. So there's a second example. And let's take a look at one more example. Okay, now this one is going to be 2x times e to the minus 3x. But again, that's something other than just a simple x, so we'll have to use substitution on this. But to begin with, go back to your list of basic definitions, and e to the x is defined to be this right here. So just like the other problems, the first thing I would always do is just write the formula down for e to the x, so you've got some beginning thing to work with. So we'll come in here and we'll put e to the x right here. Again, just like in that last one, we're going to have to change this around a bit and make it be kind of a two-step process. So step 1, we want to find not e to the x, but e to the minus 3x. And again, this is just substitution. And all it requires you to do is everywhere you've got an x, replace it with a minus 3x. So we'll have 1, then plus, and again, in place of that x, we'll put a minus 3x, then plus, and again, in place of this x, put a minus 3x, but this time it'll be squared, divided by 2 factorial. Then we've got a plus, then in parentheses again, in place of this x, put a minus 3x. This time it'll be cubed, divided by 3 factorial, and then plus, and it'll go on forever. Now it's just a matter of expanding these out. So what this one's going to be, this would be 1. Here's minus 3x. And then square both of these. So this will be plus, this would turn out to be 9x squared. And 2 factorial is 2. Then if you take the negative 3 and cube it, you'd have a negative 27 x cubed over, and 3 factorial would be 6. Then plus, and it goes on. And finally, if you can simplify it, let's simplify. So again, I've got 1, then minus 3x plus 9 halves x squared. But 27/6 will simplify, this will be a minus, will simplify down to 9 halves. So that's going to be 9 halves x cubed. And then it goes on. Okay, so now what you've got e to the x expressed in this form right here. So this right here is e to the minus 3x. And now it's just a matter of plugging in the formula like you did with the other ones. So first of all, you've got 2x, so we'll have 2x times, and in place of this, put this expanded form of the power series. So minus 3x plus 9 halves x squared minus 9 halves x cubed, and so on. And the final step is just to distribute this 2x. So 2x times 1 would be 2x. And then this times this would be minus 6x squared. So minus 6x squared. And then when you multiply this one, you would get the 2's will cancel out, 9x cubed. So plus 9x cubed. And this last term, again, the 2's will cancel out, and you'd get minus 9x to the 4th, and it will go on forever. So this is going to wind up being the solution right here. So again, it's kind of a two-step process, just like we did in that last one. Since you have something other than just a simple x, now your basic formula is e to the x, you've got e to the minus 3x. So the first step is to use substitution to modify the e to the x power series into this. Once you've got it in that, then it's just a matter of putting it back into your original problem and distributing the 2x, and you'll get the final answer. So there are 3 examples using multiplication involving power series. But in this case, we did this. You multiplied a power series times some monomial. Now, in the next video, we'll look at what happens if you multiply a power series times a power series. And it changes the way you go about it just a little bit. So we'll do that in the next video.